Hello and welcome to the 18th video that I'll be posting in my Unity platformer tutorial series. And in today's video, like I said in the previous video, we've already created our frog sprite. And what we're gonna do is we're gonna go to the programming side of things. And what I'm going to do directly is we're gonna go to our scripts folder and create a new script by right-clicking, create C# script, and I'm gonna name this enemy script. Okay, and I'm gonna double click on enemy script. And before we get to any programming, I want to teach you guys a new feature, and that is called inheritance. Script inheritance. Okay, and inside of script inheritance, what I'm trying to show you guys is I'm going to try to visualize the script inheritance so that it makes sense for you. So let's pretend we have script 1, script 2, and script 3. Okay, we have 3 different scripts. And script 1, let's say, is the parent. Okay, so basically script 1 is the parent. And I'll explain to you why is it the parent. And script 2 is the child script, parent script. And then script 3 is also the child script. And script 1, let's just say, for example, is the parent script. And so basically the hierarchy will be something like this. Script 1, and then script 2, and script 3. And then script 1 can essentially has all these variables and methods that can be applied to both script 2 and script 3. So everything that script 1 has will be available for script 2 and script 3 using a new keyword, which I will teach you when we create our parent script. But for the meantime, I want to show you that inheritance is where we avoid repetition in code. So let's just, for example, create a rigid body for our script 1, and we use this keyword so that when we want to identify the rigid body, we can just type in script1.rigidbody or something like that in our script 2 and script 3. And we don't need to type in again get component or prepare the method again, and we can just call in the methods inside the scripts. So script 2 and script 3 will avoid repetition. And the way this works is that the parent script must be able to contain everything that's similar. And for example, script 1 is about vehicle, okay, of how characteristics of vehicle. So we can just say that we have the color, speed, and just say color and speed, okay? Because all vehicles will have this, right? But then script 2 can be like more specific. So we can just go to sports car, for example, or SUV car. And then inside of this component, SUV car and sports car have different features itself. So that's why the child script can take from the parent script. It can take the vehicle name, for example, and then it can take the color name, the color of the vehicle. It can take the speed of the vehicle. However, sports car itself has, for example, sports car type or brand, for example. The SUV car also has its own individual brand, and a sports car and SUV car brand are different. And what I'm trying to say here is that script 1, when it becomes a parent script, it must have all the general terms so that our script 2 and script 3 can use it over and over. So what I'm trying to say is that script 1 is going to be the parent script, and the parent script, basically all the variables and all of the methods that script 1 has can be inherited by script 2 and script 3 and used over and over. Instead of typing in script 2 this line of code, and then in script 3 we got to type in that line of code again, and basically repeats the code. So script 1 can already do that. So you just need to type in one line of code in script 1, and then we can just use it in script 2, And then we don't need to write in the type of code again. We can just directly say the variable we assign it to be or method. And in script 3, we can also just directly type in the method and the name of the variable without typing like the method itself. So this is basically inheritance. And what we're trying to do here is also similar. We're going to inherit the frog into our enemy script. So I'm going to just create another C# script in our scripts folder. So go back to Unity, go to the scripts folder, right click, create C# script, and I'm going to name this C# script frog. I'm gonna double click it so it can open. And inside of enemy script, we don't change anything because we want enemy script to be the parent. So let's just say, for example, script 1 will be our enemy script. Okay, so we will not have to see this again. And now we just say that enemy script will be the parent script. Okay, let's just think that enemy script will be the parent script. And frog will be the child script later on. And I'll explain how we make this into a child script by editing something here. So let's focus on our enemy script first. So there is the new keyword that I will have to teach you guys when we are going to create a parent variable or a parent script. And instead of the normal private, I just create a private int number like this, for example. We got a public int number two, and we have a new keyword which is protected. And protected is basically another type of public and private here, and it basically replaces public and private to protected. And protected is essentially the keyword that is used so that the computer knows that this variable can be used by the child script. And the child script will be our frog CS in this case. But I will be showing you how to use it later on in the video. So protected basically replaces private and public. And I can just say, for example, I want to take the animator because all of the enemies will have an animator, right? And I want to focus on the enemy death effect. So I'm going to change this to protected animator. And I'm going to name this enemy anim. Okay. And I'm just going to delete public and private because we don't actually need this. I'm just using that for example just now. And then we're going to go as usual to our void start. And the funny thing about having a parent script is that instead of just normal void start, we have to type in protected virtual. And this means that protected, as you know, is the keyword used so that our scripts or our child script can use the program or method and variable, while virtual is just the keyword used for the parent. Okay, so just remember it has to change to protected virtual. And then we're gonna type in our usual line of code. Once we made an inspector variable, we have to always assign that variable. So what we're gonna do is we're gonna type in enemy anim equal to get component animator bracket and then semicolon. And then now I'm also going to add a rigid body because all of these will have rigid body, remember? Because I have in my frog, I'm going to be adding a rigid body because as you can see, if we click play right now, the frog literally disappears. And you know what? I've actually solved this problem before, and I'd like to ask you guys right now to try to solve why the frog disappears. So pause the video right now and try to figure out why the frog disappears. Okay, so for those of you who know how to solve this, great job. That means you've paid close attention to the transform component position in terms of Z position. And if you don't know, then it's fine. The main camera here, as you can see, has a value Z of -14. That means our frog has to be below -14. So -13 should be enough. And when we click play right now, you can see that the frog is actually idling, but it's still floating above the ground. So that's why we need a rigid body. Rigid body. 2D. And then if we have a rigid body, as always, we're gonna have a box collider. So we're gonna type in box collider 2D, because if it has rigid body, then it must collide with something or the ground so they can stop, or not, it'll continuously fall. I'm just resizing the frog right now, the frog's box collider, so that we can be able to see a correct collision. And then we go back to our program right now. And as I said before, all of our enemy sprites will have the ability to have a rigid body and an animator. So we're going to type in again, protected rigid body 2D enemy RB, right? And then go to our animator. Then as always in our void start, we're just going to simply initialize which component we want. Get component, rigid body 2D. And then we are essentially done with this. Then we can go to our void update, and below our void update, we can create a method. And the method that I want to create is called enemy death animation. As you know, our enemy has this death effect here. All of our enemy will have the same death effect. So this is why I want to create a parent script so that all of them can have the same death effect. So we can just type in public void enemy death effect. And then at the end, we can click enter and then shift curly brackets so we can make the paragraph form. And then we can type in the code we want the computer to execute. And that is setting our enemy animation to, we want it to what? We want this to trigger, to activate enemy death effect. So enemy anim, then we want to set trigger, right? Set trigger and brackets, and then it wants an int ID, or it wants a string name, and we have a string name, and it's death. Death, and with a semicolon. And then what do we want when the set trigger is active? We want the enemy to stay in position, so we want the velocity to be 0 directly, right? So enemy RB dot velocity, and then we want it to change or don't change any position, so it becomes 0. So vector2 dot 0, which means it will directly stay in that position. And then to make sure that it doesn't even touch our object, like when it comes to crashing with our player, I want the body type to directly become kinematic so that it stays in the air, and then it plays the animation for a while, and then it dies, and then we just need to finally get components collider 2D dot enable equal false. Okay, so let's review our code right here. So enemy anim dot set trigger to death is the triggering of our animator here, death, and all of our sprites will have this. And for the meantime, we only have the frog, so of course it has it. And then enemy rb dot velocity dot equals to vector2 dot 0 is essentially where the enemy rb dot velocity equals to vector2 dot 0 is essentially the code for our enemy, so that when it's stepped or this method is activated, then the enemy will stay in position. When this code is activated, it won't move and all the velocity will be 0. And then enemy rb dot body type, and then we want it to be kinematic. So enemy rb dot body type equals to rigid body type 2D, and that is because in a rigid body here, you can remember that the body type is dynamic, and if it's kinematic, then it won't move. So this is just a precaution, and this is also a precaution. And this line of code here, get component the collider2d dot unable to false, and it's basically telling the script that the collider here, the box collider in this case, is just disabled. Okay, so we're just going to disable it by saying dot enable equals to false, and if it's true, then essentially activate it or enable the collider once more. But if we say false, then it's disabling the collider 2D. Okay, and then we're gonna add one more, and this is gonna be a private void enemy did, and I'm just gonna click enter, shift curly brackets, and just say destroy game object. Destroy, then game object, and then semicolon at the end. And we're done essentially with our enemy script. And now it's time to go to our frog CS. Now, as I said before, our frog CS here is actually going to be our child script from the enemy script. So the enemy script is the parent, and the frog CS here is the child script. And the way we can make sure that the computer understands that this is a child script is by delaying the mono behavior here to the script, and that is called enemy script. So now it'll identify that enemy script is our main parent, and our frog here will say, oh, the frog is the child of enemy script. And then if it's a child, we need to make sure that we change the value of void start or type in a new keyword, which is going to be a protected override. And override here means that we will override our enemy script here. So instead of enabling this both too, which I will get in a second, but then we will override that start with this start. So the frog will have its own start when we say override. So I'm going to type in this line of code here called base.start. And what it essentially does is we call out the base, and this is our enemy script, and then dot start is the value here. So we call out the start function of this, and the reason why I just want to override this is because I want to add another inspector value, and that is going to be our collider. So I'm going to add on top here a private collider 2D, and I'm gonna name this collider 2D a frog collider for short. And the reason why I'm not using a box collider is because colliders essentially it directly knows which collider we want to refer to, and collider is the name used for all the colliders, and it can work for any collider. But if you want to be specific, you can type in the box collider here, for example. But then I want it to be really simple, and all of the code that we've programmed in our enemy script can work with our frog here, because we use the collider here. And if we type in box collider here, then we need to type in box collider here. But then if that's only for the frog, we are using a box collider. If, for example, there is another script or another sprite like another enemy and we don't use a box collider, then it won't work. So it's better to be safe by using the collider and make it public, so that's why we can... Oh, we don't actually drag the code. So what we're going to do right now is we're going to drag the frog code here, frog script, into our frog sprite. And now it's going to ask us for a collider 2D. And basically, we can just drag our box collider into the frog collider. And there we have it. So basically, collider 2D is a general term for all colliders, and you can use any collider. So if we type in here polygon collider, for example, it's not box collider, it's a polygon collider 2D. We can drag this and we can put it inside and it still works. So that's the awesome thing about using collider 2D. So now we're gonna go back to our protected override, and then we're gonna just type in as usual our frog collider. Wait, actually we do not need to do this because we actually already initialize it here in our script. Because that's the fun thing of using the public. If we're using public, then we can just drag our box collider and it directly initializes it. So we go back to void update here. And what I want to do is I want to transition from the jump state to false, and if it's false, we go to fall or idle when it touches the ground. I'm gonna type in the code, which is going to be really interesting, and we're gonna use a lot of logic. So hold on, hold on tight, okay? Because we're gonna use a lot of logic. So we're gonna create the transition fall first, and that is if, for example, we want to check if the player or the frog here, if the frog is falling, so if it's falling, we can check it by going to our enemy animation. We can check if in our enemy animation, and then we want to check if it's falling, which means that our animator here has to be in frog fall, and this means that falling is true. So if enemy anim dot get bool, because we want to get our parameters here, and that is our falling parameter, and the parameter of falling is boolean, so we want to check if the animator, we get the bool of falling, and falling here, it's gonna ask us for string name, and we know the string name, and it's falling. So if enemy anim dot get bool, and if it's falling, then if it's true, then we click on the side, click enter, shift curly brackets so we can make the paragraph form. And this is where we put in all of our code. And before I continue, I'd like to explain enemy anim here. Where do I have this value here? We don't type anything in our public class here. We didn't even make a variable in our frog script. But in our enemy script, we create a variable called enemy anim, and it's a protected variable. So this is where inheritance happens. So as you can see, protected animator enemy anim is a variable that has a keyword protected, which means that it can be inherited by its child script. And frogcs is the child script because it uses this keyword here. So basically every variable we have here is can be accessed by a frog. So that's why I don't need to type in again or create again like public animator frog anim, and then for another animal, for example, tiger, for example, something like that, animator tiger anim, then and then over and over and over and over. And we don't need to actually do that now because we have enemy animation here and enemy rigid body. So now we just need to type in that code, and every time we want to refer to our animator, we can just type in the enemy anim instead of typing frog anim, and we have to make our own variable. So this avoids repetition, like I said before. So if enemy anim dot get bool falling, and what get bool means is not setting it, but it just want to check if falling equals to true, then we want to make sure that if the velocity 2, if the rigid body of the frog, and we actually make a rigid body for enemy, right? And it's called enemy RB. So we can just type in enemy RB dot velocity, and then we want to make sure that if the y velocity is less than 0.1, then it's actually falling, right? So dot y, and then we just, if it's less than 0.1 f, which means that it's falling here, which means if it's falling like this, then it's less than 0.1 f, and then we want to click at the edge, we want to click enter, shift, curly brackets, and put another paragraph. So we can type in our code that we want to execute, and that is, if it's actually falling, then we want it to set our enemy animation, set bool for our jumping. As you can see, it asks me for an int ID. I don't have an int ID, but I have a string name. So I'm just going to type in our string name, and then bool value. And bool value is true or false statement. So I'm just going to say false. So we set the jumping to false, and then we set enemy anim dot set bool again, falling to true. Okay, so it's just basically checking if falling is true, then we got to make sure that it's actually, the velocity is actually changing downwards. So jumping is false, and then falling becomes true. Okay, and then we go to our other line of code where we transition to idle. Okay, transition idle. So when can our frog transition to idle? And a frog can actually transition idle if it's touching the layer ground, right? We want to make sure that if it's touching ground, then it's actually just if touching ground. And what? If we touch the ground but it's jumping, we cannot also become idle, right? We have to touch ground and the state is in falling. So if the state is falling and it's touching the ground, then we transform our frog from falling to idle. And we can do that by going to our animator. And luckily, we created in our enemy script the name called enemy anim, and we can just use that to change our state. So enemy anim dot set bool, because we want to set bool to falling to false, falling to false, right? But then since jumping is false too, and jumping is false when it's falling, and then falling is false, so jumping and falling is false. So in our condition here, we said that if jumping is false, which happens when falling is true, and then if it's touching the ground, then falling is false. If it's touching the ground and the state is in falling, which means that falling is true, then enemy anim.setBool falling to false. So basically jumping is false from a long time ago, and then we just set falling to false, so that means jumping is false, falling is false, then we go to frog idle. Okay? Now we gotta type in our condition here. So if touching ground. And last time in our previous code where we did our player programming, we actually created something for this too. When it's touching ground, then we can jump. And let's see if you can actually program the, give me a second, and this is trend falling is true. Okay, so type in the code if you know for if when the frog is touching the ground. So pause the video right now and try to create a code for if the frog touching the ground. Okay, so pause the video right now and do the challenge. Okay, so if you know how to do it, very nice. It's a pretty large challenge, but you're one step closer to programming our jumping movement all by yourself. And what we're actually going to do here is we're going to type in our enemy rigid body, because we want to make sure that if our rigid body is colliding, so enemy RB, and then is touching layers, because we want to make sure if it's touching what layer, and it asks us for a layer mask, and we luckily don't have a layer mask, but we can make it now. We can make a layer mask really quick. So what our layer mask will be is going to be called public layer mask ground. And then if we control S here, then we go back to our program here in our frog, we can see that, wait, let me control S here. Oh, where is this? Oh, I see there's a programming mistake here. So anyway, we're gonna type in ground here first, but then we will assign it later. And then, and falling is true. So it means that enemy animation dot get bool. Okay, get bool. And then what do we want? We don't have an int ID. We only have a string. So we want to get bool, we want to get falling, and it's equals to true. Then I put another bracket here. Then we set enemy anim.setBool falling to false. Yeah. Now if we control S, it's gonna ask us for ground here, and we can just click on our foreground because our foreground is actually the ground in our game. Okay, and we're done with the void update program. And now we're gonna add another function. We're gonna create another method, and this method will be found below our void update, and it's gonna be using, it's gonna be called private void. And the reason why I want to make it private is because we are actually going to use something really special that Unity has, and I'll show it to you once we add that part. So just trust me that we're gonna use a private void for a sec, and then we're gonna name this frog movement because it's gonna program our movement for our frog. In our void update, this is essentially just for transitioning, and here, this is where our programming actually comes in handy, the logic. And first of all, when it comes to patrolling, I'm just gonna move the frog here. Give me a second. I'm just gonna move the frog here so that we can have a larger space for our frog to move, and we can see the movement clearly now. I'm just gonna move our player 2 here. And let's just start seeing how the frog looks. So first of all, we want the frog to look left here. It's gonna move left until it reaches one point, then gonna look right. And that is what we want the frog to do. So first of all, we gotta make sure that if it's facing left or facing right. Right? So what I'm going to do is I'm gonna create a Boolean here, not an inspected variable, but just a normal variable, and it's gonna be called a private Boolean facing left. And this will show or tell to our computer that it's facing left right now. So if our frog movement, in our frog movement, we're just gonna say if frog movement, so if, is it facing left or is it facing right? That is what we are trying to assess right now. So if facing left is equal to true, which means that the frog here is looking left, and it is right now, actually. And then we want to make sure that this code is executed, so we can click on enter, shift curly brackets to form the paragraph, and then we can type in the code we want to execute. And if facing left is equal to true, then we have to make sure that the transform dot local scale, and this is just a precaution, and I want to make sure that it is actually, when it's not 1, which means that it's -1, okay, and it's facing left, and facing left is true, and it's looking -1, and our frog call is touching layers because we want to touch the ground. It's touching ground. Then we want to make sure that the transform.local scale equal to new vector 2, and it's going to be 1, 1. Okay, so this is what's saying. If it's facing left is true. However, the local scale is -1, so basically the frog, let me go to the scene here. The frog right now is still looking, is having the scale of -1, and facing left is true, and it's touching the ground. I want it to switch because it's supposed to be facing left. So I'm telling the computer to change the frog to local scale, to transform its local scale to 1. So basically now it's looking left once more. And then if the position is already correct, then I want it to change. And I want it to move, okay? So transform dot position dot x, and then I want to say the point, okay? The point where it's maximum, where it can no longer move or already exceeds the point where we want it to rotate again. So we're gonna create those points by creating a variable so that we can actually modify them easily later when we are programming in our game. So we're gonna create a variable, just a normal variable called public float x position maximum left. So this is the maximum value of left, where if it exceeds, it have to go right, and we're gonna make the opposite for it. So x pos in right. Okay, and then we are done, and then we can go back to our program here and then type in our code, which is if transform.position.x and it is bigger than the x pos max left, then it must go to the right. We'll type in if the frog collider is touching the ground, because we don't want it to directly switch in the air. I want it to touch the ground first, then I want it to switch directly after it touches the ground. So once it touches the ground, then it can, oh wait, give me a second. It is just asking me for a normal layer mask. I'm just gonna type in ground. And then we want it to, so if transform.position.x is bigger than x pos max left, which means that it already exceeds the x pos max left, then I want it to move the opposite way and do not exceed the position. So it's gonna patrol. So these x pos max left and x pos min right is gonna be those points where we're gonna justify where the frog collider can move from left to right and right to left. And at those points, for example, I say this is point 1, this is point 2, so the frog will only move here towards the player, and then the player at the point, for example, jumps down, touches the ground, flips its face, -1, it goes here, and then, for example, this is the last point, it touches the ground, flips again, goes to the opposite direction, and so on. But that's essentially what I'm trying to program right now. And this is halfway through. So if transform.position.x is bigger than left, means here, then it is time for us to change to say that enemy dot, to say that the velocity will become new vector 2, and then we're just gonna type in the movement, how many movement we want, negative because we want it to move here, want to move it to here, and then the y value will be still 1. The y value will be jump force, or how high we want it to jump. And I don't want these to just to be normal values. I just want this to be a variable so that we can actually edit the public float, and that's gonna be jump move length, and that is for our x. And public float, oh I forgot to add the semicolon, then public float jump force. Okay, so this will be our y and this will be our x, and then we can just type in jump move length and jump force here, jump force. Now it'll move based on our jump move length and our jump force, so that we can easily change them later when we want, or edit them anytime. And then if it's touching the ground, then we know that it is time for it to actually jump. So enemy anim set bool, and what do we want to set? We don't have an int ID, we only have a string, so we want to set our jumping bool, our jumping variable in our animator here, to true. And now it basically says that when jumping is true in our animator, if jumping is true, then it'll jump, okay? And then it'll undergo the jump animation, and then we're gonna say one more statement, and that's gonna be an else statement. So if all of these are wrong, then we want it to face, right. But then since our only variable is facing left, so we can just say facing left is equals to false. Wait, equals to false. There you go. And then we can't just have an if facing left to true. What happens if facing left is false? Then there's no condition I can run to. So we want to make an else statement. Else, if facing left is true, then basically if facing left is false, then basically this code will run, and this will be basically the opposite of this code right here. So we're just gonna copy paste this code and type in our else statement and paste in our code. And so if transform.local scale is not -1, then and it's touching the ground, then basically it must be flipped to -1, because if it's not -1, that means it's 1, and then if it's basically here and it's touching the ground, and then it's supposed to go to this one, this variable here, and it says -1. Okay, -1. So it's directly switch the position to this, and then it goes to if transform position x max left. But then remember that since we want to switch this, we're going to make it to min right, and this will be flipped. Then if it's touching the ground, then we want it to jump move length normally without negative, and jump force can be negative because it's gonna make it slam the ground, not jump high in the air. And we're just gonna change the facing left to true. And then we are essentially done with our programming. Okay, so now our main problem here is the fact that the frog movement here is not executed or called in any way. And we can actually call this through a using simple method that Unity provides, and it's very cool, and only Unity would have this programming style. So what we're gonna do is we're gonna type in to our frog idle here. We're gonna go to the edge of the time, and let's just say 20 seconds here, add an event here, and basically this event will call our function, and we're gonna say frog movement. And now if we click close again here, go to our scene, click play, our frog is not going to move. You know why? Because we did not change anything. So x pause max left, let's just say, where's the position maximum? W, let's just go to 44. Let's say 44 is the maximum. And then minimum left, minimum is 63. Just make it 62 just to be safe. And then let's just say the move length, jump move is 3, and height is like 5. Okay, and let's just click play right now real quick. And as you can see now, the frog jumps and it does not idle, or it does not fall down once more. Well, the reason why is because, let me see what error we have actually. And oh, I actually found out the error here. And that's enemy RB. It's supposed to be, if it's supposed to be enemy, it's supposed to be frog call. It's supposed to be frog call here. So if frog collider is touching the ground, then it's supposed to transform to idle. So first of all, the frog will jump. And once it reaches a point, it's gonna flip, it's gonna jump, it's gonna jump, and flip again, jump, jump, jump. And that is actually the end of our video today. So we've actually programmed a lot of our enemies. We've created a lot of our animators, and what I want you guys to remember is the fact that not only Unity is using a lot of code, but we can actually program some of our code by using a event. And this event here is used for once this animation is finished, then this program frog movement here will be called. And yeah, once the frog movement is called, the code will run, and then our idle will go. So I'd love to review the code, but I think this video is long enough, and I'll review the codes on a specific video as the series continues. So thank you for watching the video. I hope you guys understand more about Unity platformer making, and I'll see you in the next video.